Today we have medium problem. Given some string with numbers and question marks. We playing the game Alice versus Bob, and the Bob wants to make the halves equal. Basically 1 plus 2 plus 3 equal question mark plus 3. So the Bob wants some numbers to place them, make him equal 6 equal, for example, 1 2, or 0 3 plus 3 6. Alice wants the opposite. She wants Bob to fail, basically make them not equal. Now the problem is marked as medium, but actually it is hard. As for me, I didn't solve it myself. Now I try to explain it how I understand it. First we this is not about the algorithm, this is about game theory entirely, so everything has to be played outside the algorithm, and we want to play it in our head. So let's start with Alice, and we want to find the corner cases of these question marks and consider all of them. And the first corner case is that if we have for example, question mark, and then some numbers 3 4, and this question mark is even, and then Alice plays like 7, Bob plays this is 3 plus 7 10, Bob plays 6, Bob wins, Alice lose. So even number didn't say us anything, but if we have odd numbers, so Bob wins. And if we have odd numbers like 3 1 question mark, and then question mark, so total is 4, and then Alice take some value like 9. Bob can play with anything else, like also like 1, for example, Bob plays, and then Alice again play like 2, and Bob play what is left. This is 13, and Bob wants to win, but he can't because this is smaller. It's 12 maximum. So basically we want to find out, oh sorry, this again is even number. Let's consider odd number. So odd number like 3 1, and then question mark, and this is even again. Sorry, let's add another question mark, and then let's add another number like 5. So this is 3. Okay, Alice first 0, Bob wants to equalize, and he said like this is 3 1 0, it is 4. Bob already loses because this is already 5. Bob lose. And let's try another example. So 3 question mark, and Alice just takes first move and Bob again lose. So this doesn't tell us anything, but actually we can tell that Alice can enforce her will if the number is even, because each time she plays, Bob plays some other number. Actually, let's look at the solution first, because I actually didn't feel myself very. So I was actually wrong. This is not even. This is odd. So for the odd, Alice can enforce her will for the odd because she has the last move. If we have even, Bob can theoretically mitigate, but if Alice has a last move, then she decides the outcome. So this is Alice, Bob, Alice, and this is the last move, and Alice can make everything for her own will. This is Alice's will, because who makes the last move? He decides if we can lose. She can make things worse, but the opposite state when Bob has the last move, but Bob have a different task. Bob has to make the halves equal, so it's a little bit harder than make things worse. You can break things very easily with Alice. Alice, easy game, because her game is to break things. So the last move, she wins. If she has the last move, she wins. And Bob is a different story, a hard game. His game is to make things equal, to build equality. And his last move doesn't tell you anything. He can still lose. He still can lose. So this, like, a half of the problem is solved, but not entirely. So if we have calculated that our count of question marks is odd, that Alice has the last move and she wins her game. But for the second half of the problem, so we have even question marks, and this is different story. The Bob has the last move, but will he succeed? Still depends on Alice will. So because she has first move, Alice enforces how things are going in the game, because she has how things going. because she has a first move. She has first move, and then that's why she enforces the Bob behavior. So any strategy that Bob would be considering, it still depends on the Alice first move. So what kind of strategy that Bob can apply that breaks the enforcement of Alice? Basically, Bob has to give up his intellect. That's how I call it, because if anything he decides to apply at any turn, his own decision, it would be just mitigation of what Alice did. So, but the nature forces is in the nature forces are decide the outcome for Bob only if he gives up his intellect and applies the mitigation of Alice in the opposite way. So imagine Alice plays with X. Then the only thing where Bob gives up his intellect and just goes with nature is when he applies 9 minus X, because this way he just applies the same strategy for the entire game. It doesn't he doesn't think at any turn what he has to do. It just applies the same strategy, and this is what means to give up his intellect to the forces of the nature. So if he does this, the nature forces come into play. Basically, it doesn't matter what Alice play. The Bob play the opposite, and that is where we starting to just use the nature forces. Basically, the entire outcome of our game steps is predefined entirely, and it's predefined by initial conditions. And basically, the only case where the nature would say that Bob would win is where Alice failed to win, and this is where, for example, we have numbers like 1, then 5, question mark. So we have 2 question marks. Alice plays any number like 9. This is already a lose. But if we have some conditions where we have this difference of the sums, of the left and right equal to what the outcome equal to the outcome after the game, so basically equal to the difference of the question mark play. And we have to discover what this is play. So if Alice plays X and Bob plays 9 minus X, and that means the difference is X minus 9 minus X equals, oh sorry, this is sum, so it is equals 9. Basically after each two step we doing plus 9 to the sum, so this is plus 9. And two step means we have for example we have two question marks. That means for each two question marks we have only 1 9. And if this is only if all question marks on the same side. That means if we should consider this question mark annihilation. So first we have to annihilate question mark that doesn't play. So if Alice takes one question mark on the left, Bob plays other question mark on the right, and they are annihilating, and basically the difference stays the same. Difference of question marks stay the same, and the difference of question marks is where the play of the question marks goes, where it's doing this plus 9 thing. So basically the difference of question marks, if for example we have two of them, and equals 9. So two question marks, 2 times different equals 9. Or this is difference of question mark, let's call it Q, divided by 2 equals 9 divided by 2. And we can say that if the difference of sums equals, so this would be difference of sums, call it as equal to difference of question mark d times 9 divided by 2. So this is a predefined combination that has to be predefined. It is the only way where Bob can win if he gives up his intellect and just plays the opposite of the Alice. And one question is why Bob plays 9 minus x, why not, for example, 8 minus x? Because if Bob decides to play this, any other number, Alice can make things for him, like she plays 9 and 8 minus 9 gives minus 1. So this is where Alice can make Bob lose. Okay, so this is my explanation of what happens behind this formula. The left part of parity is quite simple. The right part is a two-step. First you have to know how question marks are destroyed. Then you have to know that Bob always loses unless he gives up entirely and acts like he's absent absolutely and just mirrors the Alice moves, and then the only initial condition are defining the outcome. Okay, that's the problem. It is hard, I didn't solve it myself. That's it for today.